You know that moment at the gas station, the smell of fuel, the hum of the pump, and then that super satisfying click? But have you ever really stopped to think about what's going on in that split second? Well, it's not a sensor, it's definitely not a computer, so today we're going to pull back the curtain on the surprisingly simple mechanical genius behind that click.
I mean, seriously, think about it. How does this thing, this purely mechanical device, know with perfect timing when your tank is full? There's no camera, no fancy electronics, not a single microchip in sight. The answer, it turns out, is a whole lot cooler. So let's meet the unsung hero of every gas station. This isn't just a spout for pouring gas. It's a critical safety device, a really finely tuned instrument that prevents messy spills, protects your car's paint, and keeps harmful fumes out of the air. I mean, without it, every fill-up would be a dangerous, messy guessing game.
All right, so let's get right into it. Section 1. The unsung hero's click. That sound you hear isn't some high-tech wizardry. It's just a brilliant, incredibly simple piece of mechanical engineering doing its job perfectly every single time.
And here's the big secret. The whole thing works by sensing a change in, get this, air pressure. It literally uses the air around it to know exactly when to shut off the flow of fuel. Forget electronics, this is all about some really clever physics.
And to really get how this works, we're going to use an analogy so simple you could try it yourself. The whole concept boils down to a clever little trick with a drinking straw.
Okay, so picture this. You're sipping from a straw, but this straw has a tiny little hole poked in the side, up near the top. As long as that hole is open to the air, everything feels normal. But the second the liquid rises up and covers that tiny hole, whoosh, the airflow gets cut off, and instantly the vacuum inside that straw gets way, way stronger. You'd feel that change immediately, right? Well, that exact same principle is what's happening inside the fuel nozzle.
Okay, now that we've got the straw trick down, let's pop the hood and look inside the nozzle's mechanical brain to see how that simple idea is put into action with some real hardware.
The core science that makes all this suction possible is something called the Venturi effect. All it means is that when a fluid, like gasoline, gets forced through a narrow little passage, it speeds up. And as its speed shoots up, the pressure right next to it drops. This creates a small, steady vacuum, and that vacuum is the engine for the entire shutoff system.
So let's meet the key players inside. First, you've got the main valve. That's the gatekeeper. Then you have the sensing tube, which is basically our straw. It's using that Venturi vacuum to constantly sip air through a tiny hole at the very tip of the spout. Now, this steady airflow holds a flexible diaphragm in place. But the moment fuel covers that little hole, the air stops, the vacuum gets stronger, and it yanks on the diaphragm. That releases the spring-loaded trip mechanism and, click, the main valve slams shut.
And you can see here just how perfectly these parts have to work together and what happens when they don't. Under normal operation, that sensing tube is just breathing in air, keeping the diaphragm nice and stable. But look at what happens when it fails. If that tube gets clogged with a tiny bit of gunk, it creates a false vacuum. That tricks the diaphragm and, bam, the pump shuts off even if your tank is empty. It's a really precise but kind of delicate dance.
So yeah, this is way more than just a clever mechanism. It's a global safety standard. This ingenious device is a critical safety system that's become totally non-negotiable all around the world, especially with how we've changed the way we fuel our cars.
I mean, think about it. When self-service stations became the norm, the risk of somebody getting distracted and overfilling their tank just shot through the roof. This mechanism became an absolutely crucial safety net. It prevents spills, it protects the environment from contamination, and it cuts down on the harmful vapors that we all breathe.
And the economic impact? It's huge. Just look at this. The global market for these nozzles is already at $1.5 billion, and it's projected to grow to $2.5 billion by 2033. That's not some random spike. It's a direct result of more and more countries adopting stricter safety and environmental rules.
Okay, but let's be real. We have all been there. That moment when the nozzle just keeps clicking off and your tank is nowhere near full. So let's do a little troubleshooting and talk about why that happens and what you can actually do about it.
It is incredibly frustrating, right? But it usually doesn't mean the pump is broken. Now that you know how it works, you can probably guess what's going on. Gasoline is flowing too fast for your car's filler neck, which causes fuel to splash back and cover that little sensing hole way too early, tricking it into shutting off. But you don't have to just stand there getting mad. Next time it happens, you can outsmart it. Try one of these quick fixes. First, just ease up on the handle a bit and go for a slower flow.
If that doesn't work, try pulling the nozzle out maybe an inch or so, and sometimes all it takes is rotating the whole thing to a different angle to get the fuel flowing smoothly again.
Now for what is probably the most important piece of advice in this entire explainer. Please listen to this one. When you hear that first click, you are done. Seriously, stop fueling. That click is the signal that the system worked perfectly and left the exact right amount of empty space in your tank.
Because when you try to force more fuel in, topping off, you can push liquid gasoline into your car's evaporative emission system. That's a part that's only designed to handle vapor. Flooding it can ruin expensive parts like the charcoal canister, and that can lead to engine trouble and a repair bill you really, really don't want.
The auto shutoff nozzle is just a perfect example of this hidden genius in an everyday object, all running on simple physics. It kind of makes you wonder, what other simple, brilliant pieces of engineering are we relying on every single day without even realizing it?